everybody. Let's talk about how you can think about incorporating changing rates into your models. So when you were driving, we talked about you drive at a particular speed, but then you might stop for a while and then keep driving and then stop. Or if you're completing work, you might work at a certain rate. Like I'm making 5 dumplings per minute for a certain number of minutes, but then I take a break and then I keep working and then I take a break. Calculus, when you learn it, is going to give you a much more flexible, more sophisticated way of thinking about this. But for now, we have a pretty good tool, which is thinking in terms of the average rate at which work gets completed. There's going to be 2 ways to think about it. They're both useful. You should definitely know both. So here we go. Let's develop the thinking through a couple of examples that'll start easier to think about and then get more complicated until you can think about it clearly. So let's pretend that this is a graph of my work, and here I'm not taking any breaks. I'm just working at the same speed all the time. So let's say the rate is 2 dumplings per minute. That's the rate at which I work, and I work for 60 minutes. So you might ask, how many dumplings did I make in 60 minutes? And the answer is 120 dumplings. And if you think about it kind of minute by minute, here's like 1 minute, 2 minute, 3 minute, 4 minutes. So I make 2 dumplings in the first minute, and then 2 more, and then 2 more, and then 2 more. So it makes sense that for each minute here, I'm adding 2 dumplings, or, repeated addition is the same thing as multiplication. So here I've got the height, which is 2 dumplings per minute, times the width, which is 60 minutes, and that gives me 120 dumplings. Okay, let's think about that same scenario here. So if I think about my rate of work let's keep this as 2 dumplings per minute up here. So if I think about my rate of work in the first 30 minutes, I'm still working at 2 dumplings per minute. If I think about my rate of work between 30 and 60, I've got 0 dumplings per minute. Okay, the average rate at which I'm working is we'll choose some time interval that includes my break, and I'll ask what total amount of work got done in that time interval, and then how long did it take total. So if I'm going to choose a time interval that's the full hour here, in the first 30 minutes, I'm making 2 dumplings per minute, so I make 60 dumplings in that amount of time. Here, let me try and fix my pen. Okay, that's a little bit better. In the second 30 minutes, I make 0 dumplings. So if I choose a time interval that includes my break, the total amount of work that got done was I made 60 dumplings. And that all happened in the first 30 minutes. But if I'm including my break, the total amount of time is 60 minutes. So that gives me an average rate of 1 dumpling per minute. Hopefully this is giving you ideas about how you can think about this more generally, but it's always useful to be able to go back to the basic definition of what does it even mean to be an average rate. So let's try a few more. Let's say I work for 45 minutes and then break for 15 minutes, and then work for 45 and break for 15. Okay, so why don't you pause the video and think about applying the idea of average rates in this problem, and also in this one, where for 15 minutes I work at a rate, and then for 15 more minutes I work at half the speed, and then back to full speed, and then half the speed, and so on. Okay, so for this version, if I'm working at 2 dumplings per minute for 45 minutes, if you wanted to, you could break it into little 15-minute chunks. So I know that in 30 minutes I made 60 dumplings. So in 15 minutes, I would have made 30. So 30, 60, 90. So here I've made 90 dumplings. And then I make 0 dumplings. So again, if I go to average rate, I made 90 dumplings in 60 minutes. So if you simplify this, that makes 3 halves, or 1.5 dumplings per minute. Let's do the last one, and then... Well, I guess let's summarize so far. So one thing you might notice is here I am working at full speed, but half the time. That's the same as if there was somebody who was working at half the speed for the full time. So this dashed line is going to be a worker who's working at the average rate, but they're not taking any breaks. And hopefully this makes sense, because if I have somebody who works at 2 dumplings a minute for 30 minutes. They've made 60 dumplings, and then they break for 30 minutes. Let's compare how much that person made at the end of an hour to this person who works continuously at the average rate. If I'm working at an average rate of 1 dumpling per minute, and I work for 30 minutes, that's 30 dumplings. And now I work for 30 more minutes, that's another 30 dumplings. So you can see that at the end of the hour, the worker working at the average speed has made the same amount as the worker who worked at the original speed and then took a break. And that's the whole idea of an average rate. The idea is the average rate is going to end up producing the same amount of work in whatever time interval you were using to compute the average. So here I've worked, here the amount of time, or like the percentage of time I'm working is 75% of the time. So you could think about finding the average rate this way, as how much total work got done over the time interval, or equivalently, you could think about it as I work 75% amount of the time times the original rate. Therefore, my average rate is 3/4 of the original rate. So you can think about it in terms of the definition of average rate, or you can think about it as the percent of the time that I've worked times my original rate, and those are the same. Okay, let's just do one more example, because here we're imagining taking a break where I stop working entirely. What if I work fast and then slow and then fast and then slow? In this case, hopefully it's intuitive for you that the average rate should be kind of halfway in between here. But if you want to, let's go ahead and calculate it out. So here at my original rate of 2 dumplings per minute, I work for 15 minutes, so that's 30 dumplings. And then here I work at half the rate, so that's 15 dumplings, back to 30, and then back to 15. So let's add them all up. So 30 and 30 is 60, 15 and 15 is 30, and so then 60 and 30 is 90. So that gives me, it's the same as this one, that gives me 90 total dumplings in 60 minutes. So the average rate here should be 1.5 dumplings per minute, which is the same as kind of that height rate there of the dashed line. Notice that in this case, it's not as obvious how you might apply the percent time worked. Because here, it's not the case that I'm working and then breaking and then working and then breaking. I'm working at 2 different rates, and the percent time I'm working at the different rates is different. So there is a way that you could kind of extend this way of thinking to that, but I'll leave that as an exercise for you. And no matter what you do, you can always go back to the original definition of average rate. Let's close it out with one practice problem. So let's say I've got P workers. Everybody's working at the same rate of R tasks per minute, but half of the workers are going to take breaks. They're going to work for some number of minutes, M, and then break for some number of minutes, B, and then return to working for M minutes, and then breaking for B minutes, and so on, kind of alternating. I have A tasks that I need to complete, so I want a model that will let me figure out kind of how much time is that going to take if I know all those other values. So going back to our original model, we've got like the amount of work that gets done is number of people working times the rate they work at times the amount of time they work for. But here, I want to break my workers into 2 groups because half of them are going to work continuously and then half of them are going to take breaks. So really, I want to think about it this way. I've got the breaking workers and the non-breaking workers. Okay, the same basic model is going to apply to each, though. So I'm going to have some number of workers and the rate and the time and the P and the R and the T, except here the number of workers is going to be different and the rates are going to be different. So let's figure out what each of these bits are. So I said that half of the workers take breaks and half of them don't. So in terms of the workers, I've got P over 2 and P over 2, half the workers and half the workers. Everybody works at a rate of R. So the non-breaking workers for the entire time are still just working at that rate of R. So we can keep this as R and T. But the braking workers, they're going to work at a slower average rate because of the breaks they're taking. So let's think about how to compute that slower average rate. This is going to be kind of a time axis here. So they're going to work for M minutes, and then they're going to break for B minutes, and then they're going to work for M minutes, and then they'll break for B minutes. So if I want to figure out the average rate, I need to think about how much total work gets done in that time interval, and how much time does it take. So let's write average rate equals total amount of work divided by total time. Well, the total time is just M plus B minutes. How much work gets done? So here they're breaking. So they're only actually being productive during these M minutes. And they're producing R things per minute. So the total amount of work that gets done is just R times M. Because they don't produce anything during the B. So this is the new average rate at which the braking workers work. And so that's what we'll substitute in here for the rate in that part of our model. So we'll say Rm over M plus B. Finally, if we want to figure out how much time is it going to take, this model is showing the relationship between all of these variables, but I want to isolate t. So let's bring in a blank piece of paper here. I'll factor out the t in both sides here. So that gives me a equals, I'm just going to keep everything else kind of unsimplified here. So I'll have PRM over 2 times M plus B. So that's all that there. And then here I'll have PR over 2. And then I'll divide by that entire thing in the parentheses to give me T equals A divided by all this all. And I'm not going to try and algebraically simplify it anymore. But that would be a perfectly reasonable model. And again, even though there's a lot of letters here and it seems very complicated, you can break it down step by step from the original idea of the simple model, realizing that you can only calculate the productivity of the groups separately because they're working at different rates, and then think, okay, the braking workers just have a slower average rate. That's the only thing that makes them different. Okay, I hope that this was helpful.